Okay, so let's do example 2. For example 2, we have a plane that's flying at about 30,000 feet. So that's the altitude of the plane. That's how high up off the ground it is. We'll let this be the ground. It starts its descent 130. Actually, this says 120 and this says 130, which doesn't match. So there's a typo. Let's just change this to 120 miles. So the plane starts its descent 130 miles from the airport. So this would be the airport right here where it needs to land. At what angle should the plane descend? So this is called an angle of descent. The angle of descent, let's draw a horizontal line here. We'll put theta. That's the angle at which it should descend. I'll write that down here. Right here, that angle. So I need to know how many degrees that should be. I'm going to box this off and make a rectangle out of it. And we'll say that if this is 120 miles and this is also 120 miles, this would be my right angle. And if this is 30,000 feet, then this will also be 30,000 feet. So let's find out what that angle measure is. Again, we're going to have to use inverse sine, inverse cosine, or inverse tangent. In relation to this angle right here, that is going to be the opposite leg. This side right here is the adjacent leg. I don't know the length of the hypotenuse, that length right there on this right triangle. So I'm going to use tangent because tangent theta is opposite over adjacent. That's the ratio that relates this length to this length. So tangent theta is equal to 30,000 feet over 120 miles. The units are not consistent, so I don't want to just say 30,000 over 120. This is obviously a lot longer than 30,000 feet. Every mile, I'll write that over here, 5,280 feet is equal to 1 mile. So we need to either convert to both feet or both miles. I'm going to go ahead and convert them to both feet. So that'll be 30,000 feet over 120 times 5,280 feet. And if you do 120 times 5,280, you get about 633,600. So the tangent theta is equal to 30,000 divided by 633,600. I can reduce that, divide each by 100, I'll get 300 over 6,336. I'm sure it can be reduced more, but that's good enough for what we need to do. So the tangent of theta is 300 over 6,336. So the tangent inverse of this ratio, and yes, I could reduce it, but that's fine. That's going to give me the angle measure I'm looking for right here, the angle of descent. And the tangent inverse of 300 divided by 6,336, that is about 2.7 degrees. And it should be a small angle because I wouldn't want the plane descending at too much of an angle. That could be rather dangerous for the people on board. So we're going to just say that that angle of descent is 2.7 degrees.